So I do play electric sousaphone. It is a ridiculous instrument. I think I have the only one. And it is totally related to this next segment. The next segment is about machine learning, and it doesn't actually have anything to do with it at all. My name is Miles. I run the solutions architecture practice globally for Google Cloud. What that means is I have the best job here. I get to connect with our customers that are doing the most sophisticated, path-breaking, crazy stuff and make sure that they're successful. If you heard stories from customers up here on stage, I guarantee you there's somebody from my team that's been a part of ensuring that they come out all smiles. But I will tell you something that has left people with some frowns. Anybody think machine learning sounds easy? Super straightforward. Note a distinct lack of hands up in the room. I agree with you. In 2012 at Google, there is no production machine learning usage. Does that sound like super googly and advanced? It's because it's really complex mathematics, requires advanced programming approaches, and consumes an unbelievable amount of computers. And as a result, there just aren't that many people on the planet that are all that good at this stuff. Want to get good at this stuff? Anybody want to be in the small list? Trust me, it's the people who get paid more. Okay, so if you want to be in the group full of the folks that make the extra bucks on machine learning, this is the presentation for you. Turns out, Google Cloud is here to make it so that artificial intelligence is easy and fast and useful and reliable in your businesses. It turns out, since 2012, when there was Donut, no production machine learning at Google, today, 100% of Google's services are powered or improved by machine learning. All of them. Anybody's company changed all their software in the last 5 years? Note, still, no hands in the air. Right? We changed all the software. How do you do that? How is that possible? Let me break down how that works. So it turns out, writing this kind of software is fantastically complicated until you get extra smart people to write libraries that make it easier. So instead of writing in C, then you're writing in C++. Instead of writing in C++, now you're writing in Python. There are training sessions that we do at our larger summit events that are just a couple of hours long, where we take high school students, put them through an hour-long Python class, and they're writing the same grade of machine learning code that our engineers write. Is anybody listening? There is money to be made, right? So building blocks are getting much simpler. It also turns out, even if the code gets easier, you need a catastrophe of computers. Remember the $30 billion that PH was talking about? You do get something when you spend $30 billion bucks. Works out to about a fifth of the x86 processors that get manufactured worldwide, a fifth of the computers. You power those computers with the data stored in 9 tons of disk that we add to our data centers every day. And then you connect them with a network that is 5 times the throughput of this other network you've heard of called the internet. So that platform is big enough to perform the machine learning that we're talking about. You also need this handy-dandy stuff called solutions. I'm the solutions guy, so we've got that stuff covered. There's 300 different patterns that you can follow, which are instructions on how to do this stuff without having to figure it out on your own. And those 3 pieces make it so that you can make your applications, your data, your business, your opportunities intelligent. I'll give an example. How many folks have used Gmail? Now, this is one where you get some hands. Yes, see? How many folks love replying to email? Note, less hands at this time. We put out, originally the launch for Gmail was itself an April Fool's joke, but we put out an April Fool's joke after that in 2009 that said, replying to email sucks. We'll just do that for you. We'll make it automatic. Turns out, this is actually a picture of today's Gmail. In the little lower left-hand corner, when the words turn blue, that's our machine learning system auto-suggesting the beginning or parts of the reply that you make. So we really are replying to your email for you, at least 14% of them so far. That's from good enough to be an April Fool's joke to production code in 7 years. I was the star in Google Cloud's April Fool's joke 2 years ago. It was written by Jen, who's in the back, who is awesome. And that April Fool's joke was designed to be able to take our machine learning systems and tell whether or not you were fashionable, which did not work. So that API, the fashion detection or style detection API, is a joke. It doesn't really exist. We don't have that product. Except like a year later, Amazon puts out a hardware device called the Echo Look that basically tells whether or not your clothes are fashionable. So this is the point to take away. From 2009 to 2017 is the amount of time it took then to go from a joke to production. And now it takes just 1 year. The rate of change is accelerating. Your businesses are going to change. This isn't something from the boogeyman with the red beard on stage, I promise. The data is coming, and you've got to get ready to adjust your business. And it's not just the things like you see for most machine learning examples. It's impossible. Computers don't do those things. They can't talk or reply to email. It's also for a bunch of stuff that you think you already have solved. So it turns out, just like the difference between guessing and statistics, statistics to machine learning is about the same level of accuracy jump. So you've got 10 years of super, super smart Google engineers optimizing the power and cooling systems for our global data centers, that $30 billion rack of gear. Anybody imagine those people are, one, very good at their jobs, and two, they are literally the world leaders at it. They have the most efficient power energy utilization of any data center fleet in the world. All of their software this year, we turned off. It wasn't good enough. We replaced it with a machine learning model. And if that machine learning model was 1% better, somebody's getting a Maserati for Christmas because it's millions of dollars in power saving. It works out when you turn the machine learning model on and hand it over to the computer, it's 40% more efficient. 40. So everybody gets Maseratis, right? It's an enormous difference. And one, it reduces our carbon impact, high five Earth. Two, it means that the points of your system where you think it's done, the stats have proven that we don't hire people under these situations, or we absolutely have to invest in projects that have these characteristics. Maybe those are all wrong. Machine learning might change what you vote. Turns out we're going to do this a lot, right? Google doesn't rewrite and affect every piece of software in the production business if it doesn't have a very positive impact. And if you're going to do this many of them, it turns out you need a lot of computers. So Jeff Dean, who's like a space alien super nerd, he wrote MapReduce and the ads framework and TensorFlow. So he's a relatively smart cat. And if he does the napkin math and says we're going to burn up all of Google's computers worldwide if we do translation processing on just 3 minutes of Android voicemails, he's not wrong. We're going to need more gear. So while other companies are experimenting with software for machine learning, Google is now in production with not its first, that's the upper right-hand corner, not its second, that's the ones in the middle, they're dope, the third TPU v3 hardware devices. We are building our own custom microprocessors to do machine learning faster. Because we have to do so much of it, we'd have burnt up all the computers we've got. And remember, I said we have a fifth of all of them, so it's a lot. So if you want to borrow the hardware we built so that we could do this stuff fast enough, you can. That's what Cloud Platform is. You rent this stuff by the second from us. It's really, really straightforward. So looking forward to your experimentation. Does anybody want to see what it looks like when you do machine learning live? Yes? All right. So these are the blocks for artificial intelligence development. If you're going to build some of this stuff, you just got to start gluing pieces together. So I worked with one of the hardcore architects on my team, Marku, in India. We did this 2 weeks ago. So now I'm like, you got to cross your fingers. We're going to try and do it live here. And I wanted to do it for local stuff. And I like toys. So who likes the Avengers? Yeah? OK. Switch over to the demo machine. So I have all of them. This is Thor without his cape. And I bought a bunch more. I think, yep. Here's Captain America. So we got a whole bunch. So what we did is we took several hundred pictures of these characters and uploaded them to a product on our side called AutoML. And then we're tying that machine learning model that was automatically built. I don't know jack about machine learning code. I just gave it my pictures, and it works. Then I take the output of that machine learning model, which is text, because text is boring. I wanted to make it so you could hear it, so we hooked it up to our speech engine. So you should be able to hear the thing talk.
Cloud Auto ML, Cloud Vision API.
So I send the text
Cloud Auto ML.
Cloud Auto ML, and it says it out loud. That's not all that tough, but it's built in. This model, the plain model,
Cloud
the
Vision
standard
API.
model, is hooked up to this little camera in here, and it's really geeky looking. So what you're going to see is the ceiling, right? Here's my hand. There's the ceiling. There's his screensaver. And here, if we get it around, you'll see there's you. Hi, all of you. So if I take a picture of the Hulk right now, it won't know what's up. It'll go, well, I think green. That's the standard Vision API. It's not wrong. This is green, but it's not very accurate. So let's say
Cloud Auto ML.
now we've used the AutoML for Avengers. I take a look at it. Here's this guy. And it thinks about it for a second, and then it says something like a demo that works live on stage. Come on. Maybe not. Come on, computers. Oh boy, this is gonna go great. I knew these demos were a good idea.
The Incredible Hulk.
Yeah, all right, there we go. So let's do Iron Man while we're at it. While we're in the lead, let's do one quick.
Iron Man.
Yeah, okay, there we go. So back to the slides. So this demo is a net sum of 16 lines of code. It took our team thinking about it for like 3 hours to make sure it was funny, and then coding it for about an hour and a half. So that, if you think you have a spare hour, maybe you want to put some machine learning in your apps. We have that stuff for translation, for vision. We're doing it now in natural language processing. We can do it with speech to text and text to speech. We can do it in your videos. And we're extending the capability of making machine learning easier for all businesses all the time. And I want to leave you with this concept that when you imagine the power of what's happening in machine learning, when we talk about the trillions of dollars that this opportunity represents, recognize that it's not for your data science team or the folks that are working in your analyst group or even the people that are working on the applications. It is for every part of every business in every vertical, everywhere. And Google just brought a data center up the street so you can do it right here better than anywhere in the world. Thank you so much for taking the time.